Hi folks, Mr. Long here. We're going to do some graph sketching. We're going to look at the chain rule. We're going to look at general derivatives of y equals b to the x. So just as a quick review, remember that when we did this in class, we had d by dx, 0.693 times 2 to the x. So remember that it was a vertical scaling. So the derivative of 2 to the x is 0.693 times 2 to the x. The ln of 2, if you do that in your calculator, you're going to get 0.693. Something interesting there, right? So remember that ln 2 equals 0.693. d by dx e to the x equals 1 times by e to the x, because they're equal. The derivative of e to the x is e to the x. And we know that the ln of e to the 1, or ln of e, is 1. So I think we can tell the next one as we go across here. I believe that this was 1.099 times by 3 to the x was the derivative of 3 to the x. And I'm pretty sure if you use your calculator, that's what you get for the ln of 3. So the general derivative then is d by dx of b to the x is ln b times by b to the x. Remembering that ln b is just a number. That's all it is. It's a number. It's a vertical scaling or stretch or compression of the original exponential function. Okay, with the unique one being e to the x has the same derivative. So remember that the derivative of b to the x is just a vertical stretch or compression of b to the x, which I call a scaling. Okay, so what's the derivative? Let's do some examples. What's the derivative of 7 to the x? Ln 7 times by 7 to the x. Okay, that is the derivative of 7 to the x. Now, can we figure out what ln of 7 is? This, and I could write this if I wanted as 1.95 times 7 to the x, right? So again, that's a vertical scaling. So that's interesting. That's close to 2. So that means that if you had bacteria that was growing at a rate of multiplying by a factor of 7 every hour, that the rate of change would actually be double that, is double the value of the number of bacteria. So that's something that would be growing very, very fast if it's multiplying by a factor of 7. Okay, so now let's look at a chain rule example. Now, what I would like you to do with the questions like this, even though you know, you might recall that I often forget to do this, that -4 is a coefficient. It doesn't matter if I include that inside or outside the derivative. So what I'm going to do is I'm going to write this as -4 d by dx of 1/2 to the cos x. Okay, so whether I have -4 times 1/2 to the cos x and get the derivative of that, or if I get the derivative of 1/2 to the cos x and then multiply by -4 at the end, I'm going to get the same result. So how do I do this? Well, this is a chain rule question because I have a function inside a function. So the inside function in this case is cos x. So that's the inside equals cos x. And the inside prime would be negative sine x. And then the outside function would be 1/2 to the bracket, right? Which, I could put the u, or substitute u or f or g. And then the outside prime would just be ln of 1/2 times by 1/2 to the bracket. And we know what goes in the bracket, right? We definitely know that. So there's your inside derivative, there's your outside derivative. Multiply them together. Okay, multiply the inside derivative and the outside derivative together. And again, you can use those substitutions that I used in class, or you can do it this way. You're at the point now where hopefully you're starting to get the hang of this. Okay, so when I go to combine those, I need to multiply those together, the inside and the outside derivatives. What's going to come first, sine x or ln of 1/2? Well, you're probably going to want a coefficient first, which is ln of 1/2. So I've got to multiply the negative and the ln of 1/2. So this is going to equal -4 of, -4 of negative ln 1/2 times by sine of x multiplied by 1/2 to the bracket. And what was in the original bracket? Cos x. So when I simplify that, I've got a negative times by a negative. So that's going to become 4 ln 1/2 sine x times by 1/2 to the cos x. Okay, so that's the derivative with the chain rule. All right, so now what we're going to do is we're going to slide over to this side, and we're going to use the product rule with the chain rule. Okay, and then we're going to do some graph sketching. Okay, we're 6 minutes in here, so yeah, let's go through this. So I'd like to do some simplifying here. Let's take a look at this. So d by dx, 2x times 9 to the negative x over 2. So I see the chain rule there because I've got negative x over 2. If it was just regular old x, I'd be fine. But I have negative x over 2. But let's see if we can do some simplifying first. So the first thing I notice is there's a coefficient of 2. So I can take that outside the d by dx. But then I've got something here, negative x over 2. Well, that's going to be x multiplied by 9. But then negative x over 2 would be negative 1/2 of x, right? So think about that for a second. Negative x divided by 2. Dividing by 2 is the same thing as multiplying by 1/2. So negative x divided by 2 is the same thing as negative 1/2 of x. Now, we know from our exponent rules, that's an interesting thing. Exponent of 1/2 is square root, and a negative exponent means division. So what does that mean? 2d by dx of x multiplied by 1/3 to the x. Okay, that's what we have. So again, I'll repeat. Base is 9. Exponent is negative 1/2. Exponent of 1/2 is square root. Square root of 9 is 3. But because we've got that negative there, that means it turns it into a fraction, right? It's repeated division instead of multiplication. Or in this case, a root. So there we've got x times 1/3 to the x. Well, now I've got no need for the chain rule, but I definitely have the product rule with a and b. Okay, so let's go through that. So in this case, a is worth x. A prime, the derivative of that is 1. B is 1/3 to the x. And we know that b prime is ln 1/3 to the x. Okay, so ln b times b to the x. And then I put it into the formula for the product rule. A prime b plus ab prime. So a prime b is 1 times 1/3 to the x. 1/3 to the x plus sine a b prime. X times, here's where, see, and that's a perfect case where I'm just going to scratch that out. So remember that I always like to look at these before I actually multiply them. Think first, write second. So I've got ln 1/3 times by x, or sorry, ln of 1/3, 1/3 to the x times by x. So which of these is a coefficient? Is x the coefficient here, or is ln of 1/3 the coefficient of here? So ln of 1/3 is just a coefficient. Then I multiply by the x, and then it's 1/3 to the x. Again, I could put that in the opposite order. I could put it as, and I should put that in the bracket there. I could have had the 1/3 of the x multiplied by x, it wouldn't matter. But this ln of 1/3 is a coefficient. Now, that would give you full marks if it just said differentiate. But we're going to go on and do a bit of graph sketching in a minute. What I'm going to do is simplify that as if I was being asked to simplify it. So do you see a common factor here? Well, I think I do. I see 1/3 of the x and I see 1/3 of the x. So I could factor out 1/3 to the x, and then now I divide. So now it's 1/3 of the x here divided by 1/3 of the x. That's 1. I've got my plus sign, and then again I'm dividing that out, 1/3 to the x. So I'm left with ln 1/3 multiplied by x. Okay, and that's that would represent a simplified version. Now, what if I was asked to solve to get the, if I was going to graph sketch and I wanted to get the critical values. So to get the critical values, I have to set y prime equal to 0. And you know what? I'm going to do this on our next video, just to keep the videos at a reasonable length. Okay, so I'm just going to write this over here. 1/3 to the x multiplied by 1 plus ln 1/3 multiplied by x. And that's going to help us work through the graph sketching. And we're going to set that equal to 0. Okay, folks, and that'll be on our next video. So again, pause, rewind, go through it again, make notes, etc. Yeah, I think so. So we can do that. Let's get the ln of 7. Oh, whoops, there. So functions, function, and we can get the ln of 7. The ln of 7 is 1.946, or 1.95. 1.95. So then I can go back to